So now the curl. I still have the function here where I determined the divergence. I'll link the video. Now let's build the rotation on top of that. I've also left the divergence here again so you can understand the difference once more. Divergence is the derivative operator and the vector field. And what comes out is a value, a scalar. And with the curl, we now have the derivative operator, and then in the vector product, vector cross product with the vector field. And you can also derive that again. You don't always have to memorize the formula. I'll just do that here now. Otherwise, you can skip ahead if you just want the calculation. We have the derivative operator, partial derivative with respect to x, partial derivative with respect to y. So partial derivative with respect to y, partial derivative with respect to z, and the whole thing in the vector cross product with f1, f2, f3. And I always do it like this, that I write it underneath each other. So partial with respect to x, partial with respect to y, partial with respect to z. Yes, you wouldn't have to write that here anymore, f1, f1, f2, and f3. Cross out the first and last ones. Here, the entry is now partially derived with respect to y. Well, let's get started. So this would now be the first value, partially derived with respect to y, f3, minus the partial derivative with respect to z of f2. The second value, we move one down, partial derivative with respect to z of f1 minus the partial derivative with respect to x of f3, and then the last value, partial derivative with respect to x of f2 minus the partial derivative with respect to y of f1. Yes. And what comes out here is obviously a vector, right? Let's go through the individual components. That would be, in our case now, so if we look at f3, take the partial derivative with respect to x. Take the derivative with respect to y. In this case, it would be 2z derived with respect to y. Keep your eye on the y. 2z times y would be 2z minus f2. We then take the partial derivative with respect to z. Now this requires a bit of concentration. 3x squared drops out. For minus 2 sine yz, the minus 2 stays. The derivative of sine is cosine, so cosine yz, and since we're differentiating with respect to z, the inner derivative would be y. Take the partial derivative of f1 with respect to z. Let's take a look at f1. Partially, with respect to z, the partial derivative here would be 0. Minus, let's take a look at f3. f3 partially differentiated with respect to x is also 0. And then down here we have the partial derivative with respect to x. That should be f2 here. Look at f2. The whole thing partially differentiated with respect to x is 6x minus this here. Partially differentiated with respect to x is 0 minus. Look at partial f1. Differentiating with respect to y gives 4. That would be the whole thing. It basically means once you've recognized the math vocabulary, the danger is gone. Divergence, as I said, was also worked out and derived more generally in the other video. Now for the curl formula. Either you can use the formula, have it somewhere, or quickly derive it yourself accordingly. And then it requires a bit of concentration. So that you don't get confused with these partial derivatives and understand accordingly, divergence gives you a value, a scalar, and curl gives you a vector. And then, with the corresponding exercises, you should hopefully get through easily.